my dad worked at CAT, and he holds several inventions in the areas of tractor design and transmission design. And I've spent the greater part of my 24 years at CAT working to achieve near zero emissions out of a diesel engine while maintaining customer value. And that's a theme of the talk we're going to have today, in this customer value. And that goes all the way back to the invention of the track-type tractor. So we'll talk about that and how it came to pass. Before the track-type tractor, there were no tracks. There was tractors, but they were terribly inefficient. Tractors back in the early 1900s would weigh 30,000 pounds, so very, very heavy. And in order to avoid compressing the earth, employed 6-foot-tall steel wheels, banks of them several feet wide, so that the tractor would be 30 to 40 feet wide. And it was a dog. It had less than 100 horsepower. So let me ask the guys in white, is that customer value? No! So, Holt thought there has to be a better way, and he invented the track-type tractor, so to replace that wheel with the track. But Holt had another problem to solve, and that was a problem of power density. The tractor was still a dog. So Caterpillar put diesel power into the track-type tractor, and old Betsy, we like to call her old Betsy, 1931, first diesel-powered track-type tractor. So she's now in the Smithsonian Institution because of the important impact she had on our industry. Why? Dramatic impact on fuel consumption, dramatic impact on owning and operating costs, easier to maintain. Now, that's 100 years ago. Here we are 100 years later, and what comes out? That D7E, and it has the very same improvements that old Betsy had all those years ago. So it's generations. Let's hear it for that. Now I want to talk about inventions and innovation and what's the difference between the two. There are a lot of people that can invent something and come up with a gizmo. At Caterpillar, though, we expect our engineers to do three things. We expect our engineers to innovate simultaneously to improve sustainability, and that's sustainability to two things: sustainability of our customers' business and also sustainability of the environment. We ask our engineers to innovate for customer value, help our customers make more money with Caterpillar products than they make with the competition, and we ask them to leverage engines, hydraulics, transmissions, the integration that Caterpillar has, and stand on the shoulders of the engineers that came before them and leverage that legendary Caterpillar value. We expect engineers to simultaneously do all three of these things. So let me ask you this question. If you have an invention and it does not simultaneously meet all three of these things, is that an innovation? No! We expect them to do all three things at the same time, and that's what we call the power of and. Now, it's a tough job, but we've got 8,000 folks working on it, as I said, and we're giving them a lot of money. They spend $7 million in R&D every day at Caterpillar to improve the equipment and the engines that we have. That's innovative thinking. Innovative thinking that led us to proprietary heat treat technologies that make Caterpillar products more durable than the competition. Innovative thinking led us to assert technology. Innovative thinking led us to what we have right there in that track-type tractor. Now, we think of that as being an electric drive tractor, and we think the electric drive is the invention there. Really, I guess it is an invention, but the innovation really comes in how we take that transmission, that electric drive transmission, and couple it with the engine and integrate them together, and then we build the tractor around that powertrain to create superior value. That's what we call systems integration, and by leveraging what we have in the Caterpillar product family and the components up to the machines, that's what enables us to have a competitive advantage. Caterpillar machines last 10, 20, 30 years, and they're a wonderful asset. In fact, the machine that you see right over there, the 980, you notice it has a little bit of a rust on the bucket. That machine came to us, actually to Wayne Supply, one of our dealers, for a certified rebuild. You see, that's the 5,000th machine we've had rebuilt. And what we did there, we took that machine, had 30,000 hours. Now, 30,000 hours doesn't mean much to you folks, but think about that. If that was your car, that'd be 1.2 million miles in your car. What would you do if you had 1.2 million miles on your car? You'd throw it away, right? It'd be good for the junk heap. We breathed a second life into that. We took that machine from Tier 1 emissions to Tier 3 emissions. We lowered the owning and operating cost, and the best part is 90% of the iron on that wheel loader was rebuilt back into it. Now that's what I call sustainability. Now I met a great guy today. He came in here to have Mike Rowe sign something. Now most of us had Mike Rowe sign a hat. This guy has a wheel loader, 980 wheel loader, 41,000 hours, and we told him he loves his wheel loader. We told him about this program, but he doesn't just love his wheel loader, he loves CAT. Now young people, what do you do sometimes when you love something? What do you get on your body?
A tattoo.
A tattoo. Yes, this guy had a CAT tattoo with a CAT logo on, and I want to know what colors were the tattoo?
Black, yellow, black, yellow, black, yellow.
Yes, so that's the kind of loyalty that we have and our Caterpillar customers. That's probably the best story I've got to tell about Conexpo. Now, talked about rebuilding stuff that we've got out there in the field. Let's talk a little bit about what we're doing for the future. Let's go back to the way engineers look at the world. We really kind of look at the world thinking of energy, going back to how do you take the energy and fuel and turn it into work at the implement. That's really how we think about things. So let's start with the energy and the engine. The engine, diesel engine, as wonderful as it is, good, efficient power plant, is really only about 40% efficient. So we're looking at higher firing pressures, new injection type systems, and we're thinking about greenhouse gas emissions. We're looking at alternative fuels. And in fact, we recognize that we don't have all of the best minds at Caterpillar. We've got some great people, but not all the best minds are there. There are other great minds out there that we're partnering with. And some of them are in Britain, and we're part of a consortium called the Energy Technologies Institute. And that Energy Technologies Institute, the British government and companies in the UK are partnering together to find ways to reduce greenhouse gas emissions. In the area of transmissions, we're thinking about energy and the waste in the transmission and the powertrain and how to make it more efficient in the machine and how to make it smoother to operate. The D7E you have here has an electric drive that's really a form of continuously variable transmission. You see another model over there, and that's our hydraulic parallel path variable transmission. We're looking at that right now for the wheel loader. And we have other ideas that we aren't ready to show yet, but we're working on a number of different transmissions. Thinking about energy and the hydraulic excavator, it's the most commonly used machine today, large machine. Think about energy there. About 50% or even more than 50% of a hydraulic excavator's energy is really wasted in the hydraulic circuit. We're spending a lot of research time, a lot of research talent to understand the sources of those energy loss, and we're going all the way back to the basic redesign of the architecture of that system itself, looking at how can we put the components together in different ways. We're looking at the efficiency of each and every one of those components. How can we make it better? What should the bends and radii look at? How can we reduce metering losses, parasitic losses, and how can we recapture that energy that's otherwise wasted? Now, some of our customers tell us that one of the biggest wastes in their operation is an inefficient operator. And anybody who's had a chance to run construction equipment know it's not easy to make that equipment perform. So what we're doing is working to make that operator more efficient by taking some functions away from him and giving those functions to the computer. We have under beta testing something today that's a coach. So imagine if you've got a wheel loader like the one over there, a wheel loader that's running in a quarry, and you might have several operators that run that wheel loader. The thing we have in beta testing today, we're measuring the performance of each one of those operators, and the computer is learning what the most efficient operator does with the controls versus what the other operators are doing with their controls, and then provide feedback in the cab to the operator so that the less efficient operator can come up to the same capability as the more efficient operator. We found that to improve productivity by 10%. Now, if you take the operator out of the equation one more step, you get to the technologies like AccuGrade. And this is where the operator has to focus on driving the tractor or the machine, but the control of the blade is computer controlled automatically, in order to cut whatever shape is programmed into that machine. Now, we started with this technology where the value proposition was highest, and that's in mining. And then the technology came down to medium track type tractors. We moved it now to excavators. We've also got it in motor graders. And you see in the North Hall here, we're launching it now in the 627. We're launching it in our scrapers. So what this enables us to do is build a road much more efficiently. One of the fun things about working at a place like Caterpillar is you get to do tests on great big things like building a road. So we had a test on building a road with AccuGrade technologies and without AccuGrade technologies. And what we found when we built the road with AccuGrade technologies, we reduced the fuel consumed by 43% and reduced the time required to build that road by 52%. So great improvement. Now, that's taking the operator out of the equation one step. What if we take him entirely out of the machine? That's a question we ask ourselves, and our mining customers ask us, how can we take the operator out of the machine? So we have underway an autonomous mining truck program, taking that man out of the machine. You're going to see that come to production from Caterpillar in the next couple years. One step to get us there was remote control and the ability to run a machine's remote control. And we got a great call a couple years ago from somebody I thought we'd never get a call from, and could be a competitor, I guess, but it was NASA. That's who we got a phone call from, and NASA was asking for our assistance in helping them to develop a remote control machine that would actually work on the moon. And when they first said that, I thought it sounded pretty far out. But you know, you've watched in the news, where's the shuttle program going? The shuttle program is going manless. And they know that they need to be able to launch some kind of vehicle on the moon and then remotely build a landing strip for that next generation shuttle. So they need remote control capabilities. When they thought, who knows controls, who knows how to move dirt, they thought of Caterpillar. So they reached out to us, and we have a program underway, NASA engineers, Caterpillar engineers collaborating together on remote control, and that will help NASA with land that next vehicle on the moon and build that landing strip. Now those guys get to work on the fun and sexy stuff. There's some folks who've got behind the scenes working on the tools that help the engineers do their job. The engineers are really born wanting to know why. Why? How does that really happen? And so how we understand that today is using computer simulation. Now some of the simulations we have to do are tremendously complex. For instance, what happens in a combustion chamber in a diesel engine where all that fuel is broken into tiny droplets and then combusts and creates emissions? Tremendously complex chemical equations. We have engineers now who are modeling that, and in fact they're working with some of the best minds in the country to help us do that out at universities and national labs. You know, it sounds to maybe some of you guys like maybe a boring job, and you might think, how does somebody get up and come to work and do that every day? Well, they have a passion for that because they're helping with this. Legacy. They know that when they develop those tools, that next generation of engineers is going to use those tools to make the next generation of products to help simultaneously fulfill all three of those principles to help that next generation of Caterpillar customers to become even more successful. So thank you, you guys, for attending today. I'll be hanging around the show a little bit if you'd like to ask some questions.
Generation Park is look this way. Yeah, yeah. Yeah, yeah. Yeah, yeah. Yeah, yeah. Do what?